Okay. How about now? Is it clear? My voice is clear.
Yes, sir, it is now.
Now I connected to the directly to the cable. I think it should be clear. Hope it should work very well. Try to fix it. I hope it should work. Okay. Yeah. But you should ask me question. It's not like one way. I don't want to teach like one way. I mean, whatever I teach is it should interact with me. Okay. Well, whenever I ask you, you should respond. Even if you don't know, also try to ask me. Try to respond. Okay. So, as we discussed this, Newton is a great scientist. Without Newton, I cannot imagine. We cannot imagine physics. Okay. So, with the help of Newton, you can explain the mechanics. You can use everything. Okay. So Newton itself, the big person, the great legend for the physics. So what he was trying to, give the contribution to the, of the optics, especially. So first person he was, thinking about the only light is the particle nature, but later on it went to the wave nature. Later on it went to the dual nature. So he is the first person who, proposed that light is a consists of a passive particle. The later on, then Young is Young. Thomas Young is the great legend, another great legend for the physics, and he proved that light has a wave nature. Light, but how did he prove that? You can ask. So he proved that the wave behavior with the help of interference. So you have to mention that light does not, light is required medium. Even it doesn't require, right? So that is his failure. He did not explain about why the light can travel in any medium. As you guys know that light definitely, the velocity of light changes with respect to the medium. So velocity of light, the velocity of light is 3 to 1048 meters per second. But when it's moving into the other mediums like, other medium like glass, okay, water, etc., it changes its velocity, right? It changes its velocity. So you can see here the great scientist, another great scientist, came to explain this optics. So light is electromagnetic, right? So light is a electromagnetic. Who proposed that? Maxwell, the great Maxwell, proposed that light does not require any medium to travel. So it can travel in any medium. It just changes velocity. It can travel in a vacuum too. The vacuum would have. So what is the light? How do we say light is the electromagnetic wave? What is this? You know that. So light is a basically, consists of what is the, as I mentioned, electromagnetic behavior. So you know that it has electric and magnetic field. It has an electric component and magnetic component. Okay. And let me draw here. Let me explain here. So you can see here, he is the one Maxwell proposed. It can go any medium. Okay, right? I have another class, but let me take 5 more minutes. So light is EM wave, electromagnetic wave. In which what are the components there? Electric components there, magnetic component, electric field E, magnetic field P, are always perpendicular to each other. So electric, you can think about this is the magnetic field and this is the electric field. They always perpendicular to each other. They also perpendicular to the propagation direction. అందుకే మనం ఏమంటాం electromagnetic wave లో E, B and propagation direction. ఈ మూడు కూడా they are perpendicular to each other. So you can see the components. What are these red colors? Arrow. Arrow is a component beta. It's a component of the electric field. So you can see that Ex, Ey, it's a vector, right? So any field, it could be electric field and magnetic field, it's a vector component. It has a component I, J, K, etc. So right. So electric magnetic, suppose magnetic field is y direction, electric field x direction, and they all they together perpendicular to the z direction, propagation direction. అంటే ఈ రెండు పర్పెండిక్యులర్ ఉంటూ అది వెళ్ళే డైరెక్షన్ లోకి మనకు పర్పెండిక్యులర్ ఉంటున్నదే దాని యొక్క ఇంపార్టెంట్ పాయింట్. మీకు ఇట్స్ ఇంపార్టెంట్ బిట్ టు రిమెంబర్. So how they, I mean, electric and magnetic field components, how they in electromagnetic wave, they are perpendicular to each other. They also perpendicular to the propagation direction. Remember that. Now we can see there is the great another scientist called Huygens. Who is that? What is trying to explain? Huygens is a great scientist to study the wave behavior, but it's kind of like, every tiny particle on a wave act like a, it act like a wavelet. It create another wave. ఇక్కడ ఉంది కదా, ఒక పాయింట్ నుంచి ఇంకొక వేవ్ వచ్చింది, ఆ దాని నుంచి పెద్దగా అయిపోయింది, రైట్? సో every dot it can create the wave, secondary wavelets, primary wave, and there is a secondary wavelet. You can see, let us say, let me draw here to understand clearly. Suppose Nana, there is a wave, or so what happened, I'm trying to explain now. Every point on the wave acts like a source for the next wave. From here another wave comes, from here another wave comes, from here another wave comes, from here another wave comes. Again here also every particle on this secondary wavelet also, it can create another wave. It can create another wave. Okay, just like this is a Huygens wave field. Every point on the wave acts like a source for the next wave. Okay, so he is also the great person to explain the wave behavior. So all this, they don't come in the exam beta. I just want to motivate you towards the optics. What is optics? Why we need to study all this stuff? You have to understand. Oh my God, this is a great animation. Are you able to see the animation? Yeah, Amulya.
Yes, sir. I can't
understand
understand what you are asking.
Are you able to see this animation, this video?
Sound waves.
No, there is no sound. It's a kind of light wave.
Doppler effect in light waves.
Light wave, Doppler effect in light. What is that actually? Do you have anything in your mind? Do you have any comments? ఏమవుతుంది ఇక్కడ?
One person is saying something to her, sir.
No, here no sound. I'm not discussing about sound. Here there are two persons. Think about two persons. So they are away from each other.
Yes,
here,
sir. They are
when
discussing.
when a light is moving from, let's say, the person A to B, like male or female, there's boy or girl there, let us say. The light is moving from boy to the girl.
Girl, yes, sir.
As light moving towards the girl, the color is changing. Can you see that?
Yes, sir. It is in red color.
Yes. Why? Why it's red color? What is going on? At the frequency of light, wave changes. The color of the light changes, right?
Yes, sir.
Why it's changing? Whenever so as the light moving from person, male person to female person, the wavelength is increasing, right? The wave చూడండి ఆ wavelength increase అవుతుంది కదా, అంటే ఆ wave pattern increasing కదా.
Yes, sir.
Whenever
It is
wavelength is increasing means what? Frequency decreases, right?
from
When-
higher.
Yeah, when suppose wavelength is higher, which means frequency is lower, right?
Yes, sir.
So do you understand what is the wavelength and what is the frequency? You guys understand? Suppose I have the wave like this, I have a wave like this. Which one is wavelength is higher? A or B?
B, sir.
A wavelength is lambda is high for A, lambda is low for B. From ear to ear is wavelength, right?
Male person has a high wavelength, sir.
మనకి ఇక్కడ అట్లా కాదు నాన్న, ఏం చేయాలంటే ఇక్కడ నుంచి ఇలా పోతుంది కదా వేవ్ కదా, and here you can see big wavelength, right? Right? Is
Yes,
it clear?
sir.
So wavelength ikkada lambda is high here. Wavelength is high this side, wavelength is low this side. This is low. Here high. Right? Whenever
Yes.
wavelength high means VGR. So V violet is low wavelength, red is high wavelength, right? Is it clear?
Yes, sir. Non-monochromatic.
Correct. Whenever you have the lower wavelength, which is actually kind of violet color or blue color, right? Whenever wavelength is high, which is a red color, right? So if the wave is moving from ear to ear, wavelength is increasing. Wavelength is increasing means it's converted into the red color. Whenever wavelength is smaller, the color
Pink.
is blue color, right? Violet color, blue color. So let me see again video now. Let us watch it again. So whenever you see again, this color is come on. So now what I am going to do? So the person initially blue color, then it becomes red color, right?
Yes, sir.
Why?
It will
Because here
become
wavelength
red.
is increasing. This is become a red and this is become a blue. Other side. This is called Doppler shift, blue shift and red shift. Blue shift and red shift in a light. So as the wavelength increases, what happens? It's a red shift. As the wavelength decreases, you call it as the wavelength decreases, you call it as a blue shift. అర్థమైందా? తక్కువ wavelength ఉంటే blue shift, ఎక్కువ wavelength ఉంటే red. ఓకేనా? Is it clear?
Yes, sir. It is.
Okay. So now the great topic, the first unit final year students, give me 5 minutes. I'm going to join. I think there are few students join in final year students. I mean, you can hear it. Definitely, it's a good topic for you also. Those who want to revise the optics. So, this is the first unit, interference. So far, whatever we discussed is introduction class. Definitely, I will revise it. Don't worry. Unit 1. What is the unit 1? I mean, light as we had a 4 units. Optics, the basics, interference, diffraction, polarization. Okay, and we are going to discuss all of them. Okay, don't worry. So, what is the interference? What is the interference? Interference. What you need actually interference? To explain interference, you need one source first, one coherent source, and there are 2 small slits, and there is a screen, and here you have the light is coming. There is a one light source which is here, let us say. So one light source is here, the waves are coming from here. Okay, then what happened? and this has a single wavelength. Single wavelength. And the single wavelength, it has only a single color. Let us say pink color. Then what happen after this point? This light wave can see two slits, S1 and S2. This is S. S is a source which is emitting the waves, and it can see two single slits which are having the same diameter, same slit. Then what happen again? There are two waves are coming out of this slit. One wave is from here, one wave is from here. Then again like this. Okay. There is a, now what is going on? I can see something here. So I can see there is a, this is a screen. So what happened here? I can call it as a S1 and S2 or the coherent sources. Coherent sources. What is coherent sources, sir? The sources which are having the same frequency, the sources which are having the same frequency and amplitude are called coherent. Okay. So the coherent sources will produce the two waves, and when they interfere each other, you have the interference. To have the interference, how many waves you need? Two waves you need. What are the conditions to have the interference? They should have the coherent source, and they should have the same amplitude. They should have the same frequency. Then only they interfere. Interfere means like this. They there is a maximum and minimum of, bright and dark fringes you can see on the screen. Okay, dark, bright. This phenomenon is called interference. Interference is a phenomenon in which two waves which are having the same amplitude frequency interfere each other, then you have the interference. Okay. So as I mentioned here, the phenomenon in which two waves superimpose to form the resultant wave of lower, higher, same amplitude, and it can be constructive interference or destructive interference, depend upon the phase. ఆ రెండు వేవ్స్ ఇలా కలిస్తేనేమో మనకు కన్స్ట్రక్టివ్ ఇంటర్ఫిరెన్స్ వస్తుంది. అవుట్ ఆఫ్ ఇఫ్ ద వేవ్స్ ఆర్ కమింగ్ లైక్ దిస్, constructive interference, one wave plus the other wave, this gives the constructive interference. One wave plus the out of phase, this gives the destructive interference. Cancel each other. Constructive interference, destructive interference. Okay. The most commonly seen interference is the optical interference or light interference. So wherever you see the two lights are coming, if someone asks you what is the condition to have the interference, they should have the coherent lights. What first point is coherent sources. S1, S2 are the coherent sources. Let me ask question. S1, S2, are they coherent sources?
Yes, sir.
Yes. Why they are coherent sources? Because they have same frequency, right? They're coming from the same source. They have the same frequency, wavelength, amplitude, everything is same. We call coherent sources. Whenever the two waves which are coming from the coherent source interfere each other, we have the phenomenon interference. అర్థమైందా ఇంటర్ఫిరెన్స్ అంటే ఇప్పుడు?
Yes, sir.
Thank you better. Finally, how many of you are like you can see here animation? You can clearly see animation here. Is it clear? Can you able to see, Nana?
Yes, sir, we can.
Yeah, you can clearly see that, right? Yes. So yeah, I'm gonna actually discuss this tomorrow class. Okay. Phase difference and path difference. What is actually? everybody, says that phase difference, path difference. You should know that what is that. Okay. I mean, I'm going to explain this tomorrow class. Is it okay?
Okay, sir.
Is it clear concept whatever we discussed today?
Clear, sir.
And you have to tell your friends. You have to each one act like you have to bring at least 2 or 3 students tomorrow. I want to see tomorrow at least more than like 30, 40, 30 students.
Okay,
Okay.
sir.
And tell your friends we're gonna complete the syllabus. Almost like a 45 days. Every day I will take class. Okay.
Okay, sir.
So we'll try to finish this, syllabus as soon as like every week. It's important. Every day is important, but you have to attend class. I want to see more students. If I don't see more students, I don't take class. So by Monday, I want to see more than 40. Okay.
Okay, sir.
Right, Nana. Thank you. Have a wonderful day. Stay at home. Thank you so much. Don't go out.
Thank you, sir.
There's a pandemic, as you guys know that. Don't go out. Okay.
Okay. Thank you
Fine.
so much,
Thank you.
sir.
Thank you, Nana. Finalist student, you can stay, and the others can leave. Finalist students, second year student, you can leave. Those who are finalists, you can stay. I'm gonna discuss modern physics, spectroscopy. Sushma, are you there? Final year students? I can see final years. I don't know how to check it. I'll just check the final years. Okay, Gautami. I can see many people. Yeah, great. See, so good afternoon, students. Good afternoon.
Good afternoon, sir.
Very good,
Good afternoon, sir.
very good afternoon, Anna, Gautami, Gopi. Gopi is final year. You're second year,
Good
right?
afternoon.
Gopi, are you second year? Final year. yeah. So yeah, it's a bad. I mean, you have complete exam so now, but anyway, we'll try to finish 6 semesters. Okay. Hope that I mean, one of the great news is we've already completed 1 unit. Crystallography lesson is all again there in modern physics too. 1 unit syllabus is same in modern physics. Almost like a 30 marks is same. Whatever the simple cubic, body center, what is the crystallography, Miller indices, the same unit is there in modern physics too. So we don't need to cover that again. I'll revise it later, but so only 3 units are there. Out of 4 units, we already completed 1 unit, and 3 more units we're gonna discuss it. So the next, the main important thing that you have to learn is quantum mechanics. That's exciting to begin. So first is I'm going to complete this spectroscopy in a week or 10 days, 10 classes. And after that, quantum mechanics I'm going to start. Okay. Can I wait or is it okay? I mean, I can see all of these people are from final year, right? Nitish, Gopi, Gautami, very nice. But still, I want to see more students. Today, I can see 14, 13 members. I'm going to share the file now. Can I begin from the beginning or student, can anyone give the response? Do I need to begin, from the beginning, or I think I took a 1 class before? Students? Or anyone? Do I need to go through again, or do I need to begin, take the, or whatever I completed last class? One is, so what is a spectroscopy? Spectroscopy is a kind of, great subject which comes in the both in chemistry as well as in the physics. Okay, so spectroscopy is such a great subject, and which is a part of the modern physics for us. So how come it is from modern? What is a modern physics? You guys know that, right? It's a modern. Definitely, without spectroscopy, you don't know what type of material it is. That's great. What is actually? So it is a kind of like, spectroscopy is a branch of modern physics which deals with like, transitions, electronic transition. How does it, takes the transition, electronic transition, rotational. So we're going to discuss all this stuff. So spectroscopy is a study of interaction between the radiation with the matter. What are the radiations, sir? It could be any type of, it could be UV, it could be IR, it could be Raman. These lights, these spectroscopy can help to understand the electronic interaction or structural information of the material. You understand? Spectroscopy is the study of interaction between the what? What happened? Can you able to hear it? Students, can you able to see that slide? Students? Hello?
Yes.
Please give a response. I can't.
Yes, sir.
Yeah, it's a branch of physics and it's a branch of chemistry too. What it deals, it just tells that interaction between the matter and the radiation, electromagnetic radiation. What is electromagnetic radiation? It could be UV, it could be IR, it could be X-rays, it could be anything. So whatever you get a spectrum from that, we can explain the structural information. Suppose me bone fracture, some person got a hurt, accident. Where we go? Hey, come on, go hospital and get a X-ray. What is X-ray? Did you think about it? It gives the spectrum. It gives the spectrum. From that, you can tell that, oh, the light passes through these. Oh, bone is fractured. The structure of the material changed. Okay. The main understanding here is interaction between the electromagnetic radiation with the atom. Okay. So the next spectrometer, as I mentioned, what are the types of spectrometers? We have a UV spectroscopy, IR spectroscopy, Raman spectroscopy, XRD. All these will give the information to measure the particle behavior. Spectrum is a plot of the amount of light observed by a sample versus wavelength. I didn't understand, sir. What is this? I'm going to tell this. It's a very basic. So what it tells you, so you gonna get this kind of peaks. Okay. Here absorption or emission by wavelength. So this spectrum related to this peak indicates something. అంటే ఈ పీక్ సంబంధించిన గ్రూప్ ఏంటనేది తెలుసుకుంటాం. గ్రూప్ అంటే ఇట్స్ నథింగ్ బట్ లైక్ ఏ ఆల్డిహైడ్ గ్రూప్, ketone group. So what is this material as? What type of atom this shows? So based on this peak behavior, small peak, sharp peak, broader peak, very short peak, based on this nature of peaks, we can tell the type of material. This is a gold, this is a silver atom, this is the copper nano atom. Okay, so we can tell that based on this spectroscopy data. The amount of light observed is called absorbance. What is absorbance? Here a sample bettina. I'm gonna keep this here sample. There is a light interacted with this sample. And you know that inside of a sample there are atoms which absorb the light and takes the transitions. So whatever amount of light absorbed by this sample, we call it absorbance. Okay. Then what I gonna ask next is what is EM radiation? I'm talking about. So is it clear? As I mentioned, spectroscopy is the. What is that? Can anyone tell that? Spectroscopy is the interaction between the electromagnetic radiation with the matter, right? Sushma?
Yes, sir.
It is a spectroscopy is the interaction with the interaction of
Electromagnetic radiation
with the matter.
and matter.
Matter and TNT, what is it? It could be liquid, it could be solid, it could be gas, right? So whenever it could be plasma. So whatever you take it, you apply the radiation on it, and it takes the interaction between the atomic level, structural level, molecular level, etc. So you all know that EM radiation is a form of energy. EM radiation is what? Actually, it is a spectrum, form of energy all around us. మన చుట్టూ ఏముంది? UV radiation ఉంది. Don't come out because there is a huge amount of UV radiation here. EM is a form of energy as both electrical and magnetic characteristics. So electromagnetic wave itself, it has a E and P, and they both perpendicular to each other and also perpendicular to the transverse direction, propagation direction. So electricity, magnetism were once thought to be separate forces, but in electromagnetic wave you can see both. So James Clerk Maxwell developed there is a theory called electromagnetism. He is the one who developed this theory, electromagnetism. So the study of electromagnetism deals with how electrically charged particles interact with each other with magnetic and electric field. There is an atom, Nana. If there is an atom here, this is a sample. You take any sample better. Whatever you sample, you take it. Okay. Each sample you have the let's say here polymer nanotubes. So whenever the light interact with the UV radiation or Raman spectroscopy, whatever you're trying to get the details, it interacts with the atoms, and it can tell the what type of interactions are going on. Are they like electronic interactions? Are there like, is there any interaction with the vibrations, with the change of polymer, CNTs, what are the nanotubes? What is the barrier for this? All this can be, you can get the data from here. So, right. So what we're gonna, this is a kind of like, very basic. Moving into the electromagnetic radiation, as I mentioned, okay, here you can see that. As you can see, electric, magnetic field are perpendicular to each other, and they are also perpendicular to the propagation direction. What happened here? So let us say this is the magnetic field and this is the electric field. If this is a Y and this is going to be X and the other one is propagation direction Z, they are all perpendicular to each other. So here the short wavelength means what? What is a short wavelength? When I say short wavelength, means that the frequency should be much higher. So lambda frequency, they are inversely proportional. The frequency is higher, wavelength is lower. Suppose VG are better. So violet as a lower wavelength, frequency is higher. Red as a higher wavelength, frequency is lower, right? And why we use the red color as a a traffic signal? Because scattering is less. I'm going to explain that later. Okay. Similarly, long wavelength as a lower frequency. So lower frequency means a cycle. I'm going to ask question for you guys. Which, this is A and this is B. So which wave has a wavelength higher? Tell me. Gautami. You can see here two waves, right? One is like this. I'm gonna do again. There is a wave here. A and B. Which wave has a more wavelength? Tell me. Can anyone tell that? Sushma, Gautami, Shailaja. So what is the frequency? Tell me. What is the frequency? What is the wavelength? Definition. Frequency is the number of cycles per second, right? So here how many cycles are passing per unit second? More, right? Here more frequency, right? Is it clear? More frequency. Here number of cycle passing per second is less, right? This is a less frequency. Is it clear? Shiva? So if this B has a less frequency, which has actually more wavelength, lambda is more. A has more frequency, less wavelength. Is it clear? Ramavat, Gautami, Linganayak. Is it clear the relation between the frequency and wavelength? You have to give your response. It's not good sitting silently. Sushma, are you there?
Sir.
Did you understand?
Yes, sir.
Did you understand?
Yes, sir.
అంటే ఇక్కడ చూసినట్లయితే వేవ్స్ నెంబర్ ఆఫ్ సెకండ్స్ కి ఎక్కువ పోతున్నాయి కాబట్టి ఫ్రీక్వెన్సీ హయ్యర్ కదా,
Yes, sir.
లాంబ్డా లోవర్ కదా. ఇక్కడ నెంబర్ ఆఫ్ సైకిల్స్ ఆర్ లోవర్, ఫ్రీక్వెన్సీ లోవర్ కదా, లాంబ్డా ఈస్ హయ్యర్.
Higher.
ఇస్ ఇట్ క్లియర్?
Yes, sir.
So you should know that. Suppose నేను గట్టిగా మాట్లాడుతున్నా, ఐఎమ్ స్పీకింగ్ సో లౌడ్లీ, so my frequency is higher, right?
Yes, sir.
Wavelength is lower. You have to remember it, guys. You should know, right? Okay. Again, you can see the definitions here: number of waves produced each second, frequency, the distance between two successive waves, wavelength, amplitude is the maximum distance of a wave. So these things you should know that I don't need to teach, because these are very basic. From here to here this is called amplitude. Okay, frequency you understand, wavelength you understand. I don't need to teach those. You can also clearly see here what is the wavelength, what is the peak. You can see here wavelength is the distance between two troughs or two crests. This is the wavelength beta. And the peak, the distance, the maximum displacement from the peak is from the mean position is amplitude. And as you guys know that this should keep in your brain, guys. It's a very important spectrum, EM radiation spectrum. When I ask you question in next class, you should be able to tell that what are the highest energy waves. You should tell that gamma rays are the highest energy, right? Is it clear? So from this spectrum, when you go from the right side to the visible spectrum, the energy goes to the lower. Why? Wavelength, so you can see that wavelength is increasing. As wavelength is increasing, frequency decreases, right? The energy also decreases. When you go from the left side, from the visible range, you can see that. Can I show here? And this is the better visible. You can see this 4,000 to the 7,000 nanometers better. VGR. So this side you have IR, infrared. This side UV, right? So you left side always lower wavelength, but higher frequency, higher energy. Then next to the X-rays, next to the gamma. This right side, microwaves and radios. Is it clear? The spectrum. Did you understand spectrum?
Yes, sir.
And you should remember these ranges. Try to note down. Every competitive exam, you're gonna see the question from here. Which of the following electromagnetic radiation have the highest energy? They're gonna give the X-rays, radio waves, UV, and IR. You're gonna tell that X-rays, right? They may create many questions from here. So which of the radiation, electromagnetic radiation, have the least energy? Radio waves. Okay, and you should be able to understand this. Again, now you can. I think it should be clear for you guys. It should be clear. See, why this is a VGR. The wavelength. See, as we go higher energy, gamma rays are the higher energy waves, right? As we go the higher energy, you can see wavelength is smaller, frequency is higher, number of cycles passing per second is more and more here. When you go right side, lambda is more, frequency is down, wavelength is higher. So this side is lower energy rays, radio waves, microwaves, infrared, lower energy rays. When you go left side, gamma very strong, ultra very strong gamma. So I'm trying to explain this with the wave pattern. So wavelength increasing means the wave, you can see how it looks. Wavelength decreasing, you can see how it looks. Okay. I'm trying to explain here what are the importance of spectroscopy. So what we do here, we keep the light and we keep some kind of like a device, prism, let it go through the, the light can pass through the prism and it can disperse into these 7 colors. And you can see one of the wavelengths we are looking here, the, let's say, green light. So I'm taking only green from here and entering into this sample. From sample, it can pass through the sample and it gives the all the spectrum here. So with this, we can tell that what is the type of this sample, what is the nature of the sample, what is the nature of the liquid, what is the nature of the matter. Everything you can get it from here. So in the next class, I'm gonna explain the old models, like what is the Thomson model, what is the Bohr atomic model, then what are the drawbacks of each model, then what is the vector model. Okay, those are the I'm gonna explain next class. Those are very important. Sommerfeld model, atomic model. So next class is going to be very important. So you can tell your friends to attend class. Today I'm not going to introduce many things. The next class definitely it's going to be so much exciting because we need to understand like who proposed, what is the first model of atomic, Thomson, Rutherford model, Bohr atomic model, all this Sommerfeld model, vector model, all this model we're going to understand actually. So, like what are the failures of each model, right? Why we need to study? What is of that model? Okay. Each person is a great legend, for the spectroscopy, like Niels Bohr, Thomson, Rutherford, okay, Goldstein, all these people they propose their models to understand this model. Okay. I hope you understand the importance of this modern physics. It's a really great field to understand the interaction between the radiation with the matter, and we can tell that structural information, and we're going to learn the lot of information in the modern physics. Okay. Any doubts, Nana? Do you have any doubts? Tomorrow I'm going to start the models, atomic models, different atomic models. Nitish, Sushma, I'm gonna hear comments from you. Is it
No
clear,
doubts, sir.
whatever we started today? Shailaja, Sushma,
Sir.
అందరూ ఇంటరాక్ట్ అవ్వాలి నాన్న, ఎందుకంటే ఇట్స్ కైండ్ ఆఫ్ లైక్ ఐ డోంట్ వాంట్ టు బి వన్ వే. ప్రతి ఒక్కరు కూడా యూ షుడ్ ఆస్క్ మీ, ఆర్ ఇఫ్ యూ డోంట్ అండర్స్టాండ్ యూ కెన్ రిక్వెస్ట్ మీ, రిపీట్. ఓకే, ఐ విల్ డెఫినెట్లీ హెల్ప్ యూ.
Okay, sir.
సాలిస్టెడ్ అంతా కంప్లీట్ చేశారు కదా, ఎగ్జామ్ ఎప్పుడైనా పెట్టవచ్చు ఎగ్జామ్. యూ హ్యావ్ టు గెట్ రెడీ ఫర్ ఎగ్జామ్స్ సెమిస్టర్ తర్వాత ఇది కూడా పెడతారు. ఓకేనా?
Okay, sir.
Already 1 month is over actually. 6th semester syllabus start. I didn't say since we completed already 1 unit, right? We covered the 1 unit in the previous semester, so that helps a lot. So I'll try to finish it. Next 4 weeks. I'll try to finish at least 2 weeks, 2 units.
Okay.
So, but don't be quiet. It shouldn't be like that. I want to be so interactive. Okay. కొంచెం అవసరం అనుకుంటే you can just go through the my I'll try to, ప్రతి క్లాస్ కూడా నేను యూట్యూబ్ లో అప్లోడ్ చేస్తాను. You can revise things. Okay, but tell to your friends, I want to hear, I want to see like more than 40 students in tomorrow class.
Sure.
ట్రై చేయండి నన్ను అందరం కూడా, మనకి ఎందుకంటే we don't have option, we have to cover the syllabus. Okay, so by Monday I want to see around like a 50 students. Okay, right, Nana? Thank you so much.
Thank you.
Right, have a nice day. Stay at home, don't come out. Okay, take care. Bye now.